Now sometimes you might have data that you find on the internet or some source. So what we're going to do in this example is show you how to get information from online sources and then stick that data into something like Mongo. This is something that is very typical for different kinds of applications where you're finding information that you might find of use. Perhaps you want to download that data and then put it into a database, and then you can access it later as you need it. So an example of this is in a data mining package within PyMongo. If you go into that, there's something called analysis data. And this is going to use a class we've called k-means data. So it's going to be used into a kind of application. It's not actually going to be a k-means cluster, but I've happened to call it that for some reason. But never mind the name. Anyways, what's going to happen here, you can see there's a method called read data. And it's going to get this data from this website called ama.cs.berkeley.edu. It's iris data, so it's kind of information about flowers, basically, irises, I guess. What it's going to do is open the URL. So there's a library within Python where we can get a URL connections. You can see we've already imported it. We're going to get essentially create a file stream to something called iris.cv, and we're going to then reference it as local file. We're going to write that information from the online source. So we're going to get the URL information, going to read it into the file stream, and that will create the file. We close the file then, so that we close the file stream that we've created. Essentially close the file stream, not close the file, but close the file stream, so the referencing is finished. Okay, and so in Mongo what we do is we're going to get the database just like before. We're going to get something called numeric data collection, a kind of collection that we create, so a sub-database, if you will. We're going to read that data, so that's going to reference that method that we just showed or discussed. And then we're going to take that iris CV, and then we're going to read that information. So we're going to open it, create it here, and then open it again. I guess that's kind of redundant. One can possibly keep it open in the first method, but that's all right. We can reopen it again. And then we're going to read that information, and then we're going to create some other sort of data which references our information, our file. So things like file, the name of the file, which is iris.cv, so type of file, and then the actual file data itself, which is called info in this case. So we're going to read that data from the file called info and dump it into something called data. That is the data for our file. We're going to have other kind of metadata associated with that located here, all in this dictionary called post. So just like before, in our specific collection, we're going to insert data, the data being the post itself. So the post has the data as well as the metadata. And we're going to insert it and get it insert ID once again, or a specific ID of insertion here, I guess, a reference, if you will, to the actual data. And then we're going to print that information. So printdb is a method that we have here where we find that data. We do a find command which gets the data basically, and it prints the sort of document information. So let's just run that and see what we get. So if we run that, we see this kind of stream of information. So that's the printdb command that you see that's printing. So we're just using the find command, basically returns everything. So we're essentially telling it here to iterate through the database, find the documents or the information from the numeric data, and to just print it. So find command is, if you don't give it a specific information in the find command, it'll get everything basically, and then that you just print everything out. So that's all this is doing, is basically putting the data into the database and then printing that information. And so the final thing I want to show you today is this kind of analysis then. So once we have all this information, how do we then actually do something useful with it? So this is a tool called SKlearn, and there's other similar tools that you might be able to find, which has a number of statistical as well as sort of machine learning techniques. So it's a kind of data mining application that allows you to take that information and begin to do something with it. So one of the things that I'm going to do in this example is use principal component analysis. Principal component analysis is a multivariate analysis that allows you to find groupings of related information and also information that has the most influence in your data. There are various principal components using principal component analysis, where essentially you have the eigenvalues and vectors that inform you how much variation you have in your data, and this allows you to differentiate key aspects of your data and thus return relationships in the data using these kind of eigenvectors, eigenvalues within your data. Okay, so I probably didn't describe principal component analysis very well. That's something you can look up online, but the point is PCA allows you, or principal component analysis, allows you to differentiate data and group them together into specific groups. Okay, so that's what we're going to do in this specific example. You can see we're going to get the Mongo database. We're going to get that data this time that we've referenced. So you can reference the specific information. So if I get the actual data that we have, so get the Mongo data. So the get Mongo data is a method that we have here where you can see we're going to get that numeric collection, numeric data. And we're going to get the ID. So remember, we had an ID, a kind of metadata information about it. So we're going to find that, and we're going to return that information. And then within that information is going to be something called documents, or data, excuse me. So data was part of that, the numeric data collection, the data actually reference. So data will then return the actual iris file, iris.cv file information. So we're going to write the file out. So we actually stored it as a file, if you recall, not actually as a, we did store it as data. It's actually as a file. So we have to actually write the file out. So we're going to do that up here. So the file is going to be written. And then we're going to get that data once again. We're going to get specific columns this time from that data. And then we're going to basically then more or less dump that information into a PCA, as you can see down here. So we're going to get that data and then create a PCA and then plot that PCA using tools within SKlearn. Okay, so all these methods that you see here, this NumB method, for instance, that's something that we've imported. So get generate from text, that's basically a method that allows us to generate a data set from just text files. So we store it as a text file because we have this NumB method that we can apply to get data. So NumB is or NUMPY, however you pronounce it, is a file, or excuse me, a library that one can get that often is used by a number of different applications, including SKlearn. So it's something that you can install in your system and then use it along with SKlearn to access information. So that allows us to access the file, and then we get the target. So that's going to be the data where we're going to dump the data, essentially. The data is going to be measured against. Sorry, I should read my own notes. So one will generate the actual analysis data, and the other will then measure against this data. So we're going to measure two sets of data. So the first 4 columns have data we will actually generate in the analysis, and then we'll use column 4 to measure against. This is something that's used in this particular principal component method, PCA, which you can look up in SKlearn. So in SKlearn, you can call this PCA, and then you fit the data to it. That is the various data columns that you have, and then you set it to the target, basically here, which tells it the specific information that you want to compare against. So if this is the data that you're inputting, this is the comparing against data, then you're sending both those into the plot command. So we're going to compare against because we want to compare it relative to something that we're going to plot. So we're going to not only do the analysis, as we saw here, so we don't need the comparing this target data for the analysis, but we do need it for when we're plotting the results to sort of compare our results that we plot relative to what's stored. That is the results, the empirical evidence, if you will, that's stored in this file. So the file has sets of data that are collected and then sets of data that are a target which we can compare our results to using this plot method. So we'll show a plot then at the very end. So these are sort of methods that are called show. You can see up here. So we're going to use this library called PyLab. It's basically a kind of drawing library, a library for plotting and drawing different kinds of output for scientific purposes. So we're going to use several different libraries in this example. SKlearn being the library for machine learning and statistical analysis. Mongo, which is our Mongo driver, which is referenced already in the actual Run Mongo, which is a library or a Python module I created, but it references the Mongo library, the PyMongo. The PyLab is another library which allows us to do some drawing and displaying of scientific analysis and graphs. NUMPY, which is another scientific library used by a number of applications, including SKlearn, in this case allowing us to open a data file and use it directly as a sort of text or data stream that we will then apply to our graph. Okay, so all these methods are basically methods that are coming in from different libraries that you see here. Okay, so and whereas the rest I've actually created myself that you see in this method in this particular module. All right, so let's just run it and see what happens basically. So once again, I Python run, and it's going to take a little while because it's a little slow. It's a fairly big data file, or a fairly big. You can see that iris.cv was created in data mining previously, so that's something that was outputted when we created it, and lo and behold, we get our output. So here, what we're seeing is different classes of data. So they've been colored in this case to show you groupings of information. So the sort of plot information that you've created allows you to then group them into different data groups. So you can see that the blue group, for instance, is more related to the red, more related with each other versus the red group and the green group. So these groupings were created by us. If you look at the plot method, 3 different groupings, or 3 different plots essentially, are applied there. In each case, we compare them to known data streams. So all that data shows that basically the target and the simulated data are fairly close to each other, or the simulated information, or not simulated, but rather the target as well as the actual data collected or generated are very similar to the data target. So the generated data is very similar to the target data, and they're colored all this kind of blue, red, and green. So it shows you the groupings that were created, the 3 different plot groupings created in line 78, 80, and 82. And then the show method simply just shows you the graph. So you can save the graph if you want as a PNG file. You can do a kind of moving around here. You can do all kinds of things. Allows you this kind of little sort of pane that's created by Python. Allows you to do some basic functionality. Okay, so that's kind of the results. You can see some other groups here of information. For instance, just look around the graph. All right, so that's basically it for this week. Now we'll pick it up again next week, or next time we meet, which I think is in 2 weeks from now, regarding how you actually get information from web sources. Okay, so thank you for your time, and hopefully this begins to help you in your work with Python and PyMongo, as well as Mongo database in general. So remember, we actually created the Mongo database, or started the Mongo database using this particular command, MongoDB, or mongod, which references a Mongo database in this example. So that's basically this example for this week.